Okay, so this video will be adding fractions with a model. Now I'm going to get into a little bit of the algorithm just because that way you can see a kind of preview and how they add together, the model and the algorithm. All right, so we're going to go back. We have 2/3 plus 3/4. Now, we have different denominators. Adding fractions with the same denominator, you leave the denominator alone and just add the numerator. Well, now you just kind of have an extra step to that. We got to turn our denominators into the same denominator. First, let's do our model. So again, 3 means that there 3 pieces make a whole. That 2 is telling me 2 of them are shaded. All right, 4 means 4 pieces make a whole, and 3 of them are shaded. All right, now I need to turn this into the same denominator. So this is how I do it. All right, I'm multiplying by each other because think about it like this. 3 times 4 and 4 times 3, they both equal 12. So I'm turning my denominators into 12. Okay, 3 times 4, 4 times 3. Whatever I do to the bottom, I have to do to the top. Okay, remember when we made equivalent fractions, how I would say 1/3 is equal to 2/6 because I multiplied them both by 2, and 1/3 is equal to 3/9 because I multiplied them both by 3. Same thing, how these are all equal, I multiplied them both by 4. 2/3 is the same as 8/12. All right, I'm going to show you how that happens. Okay, so you see how I had my 2/3 right here? Now I'm going to try and make it, there we go. That's 6, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See how I did that? Now I didn't shade anymore. I just added it in there. Multiplied by 3, I gotta multiply the top by 3. That makes this 9. 9/12 is the exact same as 3/4. Okay, I had 3/4. Now I'm making that 12. Never, my drawing isn't going to be that great. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Didn't add any shading. It's the exact same. Now, everything's normal. You guys know how to do this. My denominator is the same because my denominator is just telling me the size of my pieces. I add my numerators together. That's 17/12, which reduced is 1 5/12, but either one's fine. Okay, 1 whole. One, 2, 3, 4, 5. Okay, so real quick, I want to show you again how 2/3 is the same thing as 8/12. Okay, I have 2/3. Now when I changed my 2/3 to 8/12, all I did was I cut them up more. Okay, see how I have 12 pieces now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, how many are shaded? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. All right, I want to show you that with, let's say you do a different one. We can let's make it a little easier. 1/4 is the same thing as 2/8. Okay, so that's, say if I were adding 1/4 plus 3/8. I can change my 4 into an 8. So I multiply it by 2. Whatever I do to the bottom, I do to the top. 2/8 plus 3/8. It's 5/8. See how I just solved that real nicely? I first had a 1/4. Right? Everyone agrees that's a 1/4. Okay, now see how that turned into 2/8 right there? 1, 2, 3, 4, 5, 6, 7, 8. 2 are now shaded, but it's the same exact thing as I originally had of a 1/4. Okay, you're just changing your denominator, which means you're cutting up these pieces even smaller. All right, we're gonna go over subtracting tomorrow. And then we'll be doing estimating Wednesday.